Here you see us mixing the two parts together. For proper preparation of liquid tooling materials, please see our other video on this topic. We begin applying the 1035T onto our part with a small brush that has been cut to create a pointed end. We are making this layer as thin as possible to minimize air entrapment. One of the advantages of using this material is that it can be applied on a vertical wall. Notice how the material doesn't move at all. Here's what the completed first application looks like. After 45 minutes, we test the material to determine if it has reached the almost tack-free stage. For more information on the almost tack-free stage, please see our other video on the epoxy laminating system. We are now ready to apply our second coat. This layer will not be as thin as the first, but we aren't yet concerned with building up thickness. While our detail is mostly established, we are still careful not to entrap air. Here you see the application of the third layer. Now, with each successive layer, we are applying the material thicker because the surface of our tool is gradually evening out, allowing us to be less concerned with air entrapment and more focused on speed and material thickness. Finally, our fourth and final coat is applied. This last layer is our thickest, yet it is the easiest and quickest to apply. Here is our completed application of our glove layer using Freeman 1035T. The following day, we are using our Freeman fillet shaper tool to separate the glove layer from the frame. Next, we remove the screws on the bottom of the mold board and then remove the frame so that we can easily cut the edges of the glove layer with a knife. This step is really useful because it prevents our next layer of rigid material from pinching the glove layer between it and the mold frame. Next, we scrape and then lightly sand the mold frame to remove any excess material. Then we apply a layer of wax release to the glove layer. Here, no buffing is required because we aren't as concerned with what the surface of the backup layer looks like. We are just concerned with getting 100% coverage of wax to allow for easy release between the glove layer and the backup layer. As we reassemble the mold frame, notice the tight fit, demonstrating the low shrinkage of this material. For our backing material, we've chosen Freeman 1030, a lightweight urethane paste material that has a 1:3 mix ratio by volume and a 41:100 mix ratio by weight. When we open the B side, we notice a little separation that has occurred, so we lightly stir it until it reaches a uniform consistency, and then we measure 300 grams. After shaking the A side a little, we add 123 grams and mix the two parts together. Again, we added the B side first because it is thicker. We are now ready to apply our backing material. Freeman 1030 has a consistency a lot like peanut butter, making it very easy to apply. Since it has only 9 minutes of working time, it is recommended that you mix smaller cups of material and apply them one at a time as shown in this demonstration. Notice the color change as the material begins to cure. The thicker areas will set up quicker than the thinner areas. Here we are applying our second cup of material on top of the first. This new material will bond with the material from the first cup without sacrificing strength. The corners and the vertical walls are the most difficult areas on which to apply to get a nice thick layer of material. Here is what the finished application of our backup layer looks like. The following day, we are removing the screws from the mold board and then placing wedges between the mold board and the mold frame. Notice how the backing layer is still attached to the frame while our glove layer remains over our model. It is a good idea to mark one side of the glove mold and the matching side of the frame. This allows for quick and easy alignment of the two pieces later. Next, we peel the glove layer off of our model. Finally, we wash off the PVA with water or a damp rag. This also illustrates why we don't need any additional registration to properly align the two pieces. The irregularity of our parting line will provide a natural locking mechanism. And the mold is now ready for pouring plaster or urethane to create many accurate, easily demoldable parts. Following the exact steps of the glove molding process will work for many medium-sized projects. Here is an example of a glove mold using Blue Star's VRM65, a brushable silicone rubber, and repro laminating resin mixed with fiberglass strand as the backup material. Silicone, while being more expensive, is often preferred by those who require a very easy part release because silicone doesn't require any release agents. However, the typical glove molding process might not work as well for very intricately detailed models, such as our previous model, which demonstrates the shortcomings of this process. Since a thick material is being applied to such an irregular surface, air entrapment is almost unavoidable, resulting in minor defects as shown here. To demonstrate a solution to this problem, we've gone back and added an additional step, one that is only necessary for highly detailed models. Before applying our thixotropic layer, this time we will add 2 layers of our Freeman 1035, a much thinner material primarily used for mass casting flexible parts and molds. This material mixes at a 1-to-1 ratio by weight or volume. For this example, we're mixing 75 grams of each side into a cup, and then applying a thin coat to our model. Notice how the material puddles just a little bit in the deeper areas, which is usually where the air entrapment occurs. Using an air hose to push air over a layer may also help prevent bubbles from forming underneath. The material will thicken gradually over the gel time. After about 20 minutes is the ideal time to apply the urethane to non-critical areas and vertical walls. Here is what the completed first application of Freeman 1035 looks like. Once the almost tack-free state is reached, the second layer proceeds exactly like the first. We now have a very thin layer of material over our model, creating a smoother working surface and lessening the possibility of air entrapment as we proceed with the Freeman 1035T to complete the glove layer. From this point, everything proceeds exactly as in our earlier demonstration, with several layers of Freeman 1035T to complete the glove layer, an overnight cure, and then the application of Freeman 1030 to produce our backing layer. On the third day, we are ready to view the results of our extra effort. You can see the differences in